I know you're talking about it, right? Like where's our snow in Chicago? It's not coming with this system either. Yes, we have some snow chances coming our way. We'll get a little bit, maybe an inch or two, but that's about it here. The energy, the moisture, everything just goes farther north and farther west too. And here's where we're going to get the biggest snow. Minneapolis, we've got that chance into southeastern Minnesota. We've got that chance northwestern Wisconsin. We've got that chance. Duluth, we are also behind in snowfall. We've got a chance to make up a decent amount of it with this system. So here comes the low. This is a Thursday into Friday for your timing. There's going to be a lot of wind. And even for places that don't get the big snow, your travel is really going to be hampered by the wind blowing that snow around with this system. Then when it tracks into the northeast for your weekend, it's not an East Coast I-95 system. I mean, in fact, look at that, nothing coming in right there. But in the interior, we're going to see about 1, 2, 3 inches in a number of spots here, 5 to 8 across northern New York. We're going to watch the mountains in Vermont, New Hampshire. Great news for ski country here, Jordan.
Yeah, so
the wild, wild west keeps sending waves of storms to the rest of the country, and some think it is acting like another problematic weather system. Places like Maryville, Washington, we've been slammed by high winds. I mean, look at this. It looks like a hurricane, doesn't it? The entire Pacific coast has been pounded by the high surf, the wind, the rain, all of it. And our weather wisdom question today comes from Allison Rogers, who wants to know what makes an ocean storm different from a hurricane. They look the same, don't they? And in many different ways. But we're going to talk about the differences. I love this question because there are differences, but there's similarities. So let's just start with our ocean storm, the one after another that we've had out here across the west here. So this is the latest one. This is as it was approaching the west coast earlier this week. Look how it's all tightly wound up. There's a low pressure at the center of that. So it's a big storm system. It expands out thousands of miles when you look at sort of the wingspan of it. And when you see all these lines, these are actually isobars, lines of constant pressure. And when you have a lot of them and when they're tightly packed like this, it's a really big wind field. I want to talk about that actually. Compare that to a tropical system. There's a lot of winds with tropical system. This is Hurricane Laura as it came in and blasted southern Louisiana and Lake Charles. You guys know about the force of wind, but it actually is a much smaller, more compact wind field compared to an extratropical system. It's just that the winds can be more fierce in a hurricane in that small localized area. So a tropical system is fueled by warm waters. And in fact, it's a warm core system from top to bottom, but it doesn't have any arms, if you will, no fronts. An extratropical system or an ocean storm, it has fronts. It is fueled by the temperature contrast that exists in the atmosphere. The wind, I mentioned the wind, and you know the extratropical systems or ocean storms are big and expansive and have a large wind field, but a tropical system, as strong as the winds are, usually are confined to a pretty small area. This is Hurricane Iota here when it was approaching Nicaragua and Central America. Look at the ocean storm, and it's a strong low pressure, just like a hurricane is a strong low pressure, often most of the time actually stronger than these ocean storms. But this one, very intense. This is what we're dealing with right now. It was 962 when it was at its peak, and it sent out the wind. It sent out the waves over a very large area. And oftentimes these ocean storms or extratropical cyclones create a big wave field, even larger than a hurricane would. It's been affecting us on the entire west coast here of the United States. So keep those questions coming. The wild, wild west keeps sending waves of storms to the rest of the country, and some think it is acting like another problematic weather system. Yeah, like something in the tropics. All right, places like Maryville, Washington have been slammed by high winds. I mean, look at this, the rain, everything blowing in the wind. The entire Pacific coast has been pounded by high surf. And you might be wondering, is this a tropical system? No, this is a big extratropical system out there. And our weather wisdom question today comes from Allison Rogers, wants to know what makes an ocean storm different from a hurricane. All right, so let's talk about this because there's similarities and there's differences. And we'll start with the big storm that we've got coming in right now to the northwest here. This one has been blasting, and this is what it looked like when it was approaching earlier this week. Look how tightly wound up it is. This is a low pressure. Just like a hurricane or a tropical system, the center of it is a low pressure, but they're very different actually in the way they form, the way they get their energy, the way that they are set up, the size. So this is an extratropical system, and you see these isobars. These are lines of constant pressure, give us a good feel of the wind field. Look how it fills up almost the entire Pacific over here in the Western Pacific, in the Eastern Pacific. So we are looking at a very large wingspan, if you will, with these extratropical systems. Now, a hurricane has some fierce winds and usually even stronger winds, right? But it's much more compact in size. Think about Hurricane Laura. That was Laura when it made landfall. With the strongest of the winds, we're right there in southwestern parts of Louisiana and really didn't extend much further than that. This is a wind field of a tropical system. This is Hurricane Iota, and you can see how the strongest of the winds are actually pretty compact, only impacting very small area of the coastline of Nicaragua with that wind. So it's a small but fierce wind field. And when you compare a tropical system and the way it forms over warm waters, that's what gives us its energy. It doesn't have any arms, if you will, no fronts that go along with it. Compare that to an extratropical system, which has the fronts and actually gets its energy from temperature differences in the atmosphere. They are very different in that way. And here is that intense 962 millibar low pressure that we had approaching the northwest. This is when it was up in Alaska, that Aleutian low. It's a strong low pressure, and hurricanes can be even stronger when it comes to low pressure, but these extratropical systems can be even bigger in size, and that can create even bigger impacts. So we saw waves from this thing emanating out and affecting the entire west coast of the U.S. Keep those questions coming on social media, either tag